Pre-calculus 7.4, day 4 notes. First of all, we have a warm-up, just reviewing the past couple of days. And so the first thing you need to do is factor the denominator, which is an x minus 3 and an x plus 2. Since those are linear factors, we're just going to use a over x minus 3 and b over x plus 2. If we multiply through by the least common denominator, clearing out the fractions, we're left with x plus 1 equals a times x plus 2 plus b times x minus 3. Now on the right-hand side, you want to distribute. And then put the like terms together. So we have an ax plus a bx. And then the constants will be the 2a and the minus 3b. And if I pull out the x, the coefficient of x is a plus b. And then the constant's 2a minus 3b, which gives us the system a plus b equals the coefficient of x, which is 1. Again, that is because the coefficient here of x is 1, and the coefficient of x has to be a plus b. And then for the constants, the constant on the left is 1, and the constant on the right is 2a minus 3b. And so 2a minus 3b has to equal 1. And now you have a system to solve. And if I take the top one times 3, then the b's will be opposite in value, so that when I go to add them, the b's will cancel out. So we're using elimination. And you get a 5a equals 4. And then I'm going to use the fact, that a plus b is 1. Oops, I forgot to solve that. So a is 4/5. And then substituting 4/5 in for a, if I subtract, I get b is 1/5. Now, how do we write this? Well, we're going to use that a is this and b is this and plug them back into this expression. So I get 4/5 over x minus 3, plus for b it's 1/5 over x plus 2. But we're not going to let you leave it that way. We don't leave fractions in fractions. So this is equivalent to taking 4 over 5 times 1 over x minus 3 and taking 1 over 5 times 1 over x plus 2. That is equal to the above statement. And so then we're going to write the 4 in the numerator, and we're just going to, undo that part. We're going to put 4 over 5 times the quantity x minus 3, and we're just going to leave it that way. 1 times 1 is 1, all over 5 times the quantity x plus 2. And that's how you take care of fractions. You can go right from here to that step if you're comfortable with doing that. All right, so for example here, you're going to factor the denominator. And that x cubed plus 8 is a sum of cubes. It factors x plus 2, x squared minus 2x plus 4. Just a reminder, a cubed plus b cubed factors binomial times a trinomial that has the opposite sign. And it's not a 2ab in the middle, it's just a minus ab there. That is how you factor a sum of cubes. We expect that you know that. So now, when I break this apart, I have a linear factor of x plus 2, so I can just use a over it. But then the next denominator is of degree 2, so I need an expression of degree 1 in the numerator. And so that's where we need to use bx plus c. And if I multiply through on both sides, to get rid of the denominator, I'm going to be left with 2x, and a is going to be times this x squared minus 2x plus 4. And the quantity bx plus c is going to be times x plus 2. So expand. We have an ax squared minus 2ax plus 4a. And then we have a bx squared plus 2bx. As I distribute bx, distribute the c, I have a cx plus 2c. And then I am going to rearrange this so that all the x squared terms are together, and then all the x terms and then the constants. And then I'm going to take out the x squared. So a plus b is the coefficient of x squared. I'm going to make it plus, and then inside, when I take out the x, I'm going to make this a negative 2a inside, plus 2b plus c, all times x, and then our two constant terms. And for the system, please put the brackets around it. For the a plus b, on the left-hand side, there is no x squared term. So the coefficient of x squared is 0, so a plus b is 0. However, when it comes time for the coefficient of x, we know that is equal to 2. So a minus 2a plus, 2b plus c equals 2. And then there isn't a constant term. So when it comes to the 4a plus 2c, there's no constant on the left. It's just a plus 0. So the 4a plus 2c is going to be 0. So now there's some choices in terms of how you want to solve this. This first one, since a plus b is 0, that means a is equal to a negative b. And then I'm going to substitute that both into equation 2 and equation 3, if this is equation 1, 2, 3. And so in for a, I'm putting a negative b, so I get a minus 2 times a negative b, because a is a negative b, plus 2b plus c equals 2. In equation 3, I get 4 times a negative b plus 2c equals 0. So I substituted negative b in for a into both of those. So these simplify. You have a plus 2b and another plus 2b is 4b, plus c is 2. And then we have a minus 4b plus 2c is 0. And so we could go right to adding those. I'm going to call this equation 4 and equation 5 because the b's are opposite in value, and we get 3c is 2, which implies that c is 2/3. And then if I substitute that back up into either of these, I have that 4b plus the c of 2/3 equals 2. If I subtract 2/3 from 2, I get 4/3. And then if I multiply or both sides by 1/4, I get b is equal to 1/3. And then a is the opposite of b, so a is negative 1/3. But now I need to take each of these and plug them in up above for A, B, and C, and then rewrite it. So I'm going to come in, use this space right up in here, and I have a negative 1/3 over x plus 2, plus I have bx, which is a 1/3 x, and then plus 2/3 for c, over x squared minus 2x plus 4. And then this first one's going to be a negative 1 over 3 times x plus 2, as I talked about how the fraction comes out and multiplies in the warm-up. In the second part, it's a little bit more work because I want the fraction out of both terms, and so if I pull out a 1/3, I get an x plus 2. I have to do that first. So then this is a negative 1 over 3x plus 2. And that 1/3, the 1 is times the x plus 2, and the 3 is times the quantity in the denominator. And that's my answer.